talk about graph operation, which is the part of our CI component A. So before starting about what are the 6 operations which we study in this video, we learn what are the graph operations. So basically graph operation involves the manipulating the structure of a graph. A graph will be given, we will manipulate its structure by adding or removing the vertices and edges, or by combining existing graphs we form another graph. So that is what graph operation do.
So the first type of operation is the union operation. So we will take two graphs G1 and G2. So and G is equal to G1 union G2, where vertex set B is equal to B1 union B2 and the edge set E is equal to E1 union E2. So we have two graphs here. This is the graph G1 and this is the graph G2. Now we take a graph G, which is the union of G1 comma G2, G1 and G2. So we will match all the edges that are here in G1 and G2 on this graph. So we will first join the edge AB, which is 1, AC is 2, BC is 3, CE is 5, DE is 6, BD is 4 and BF is 7. Now we will match all the edges in this graph onto this one. So AC here is 9. There is already an edge on AC, so we draw another edge like this, which has a weight 9. Then BC is 3, which is the same line, the same edge here. Then BD is 10. We draw another edge, which is weighted 10. Then we have BE. We join the edge BE here with weight 8. And DE is 6, which is the same here. So now we have formed a graph, which is G, B comma E, which is the union of the graph G1 and G2.
So the second operation is the intersection operation. Again we will take two graphs for this. The first graph will be G1, which has vertex B1 and edges E1, and another graph G2, which is represented by vertex B2 and edge E2. And these are two graphs. And then we have to find the intersection between both the graphs. And the intersection will be represented as G. And where the vertex set is B equals to B1 intersection B2 and edge set is E1 intersection E2. So if we see the example, this is the first graph where A, B, C, D, E are the vertices and the line joining them are the edges, and this is a loop. And this is the another graph which again these are the vertices and these are the edges and these are the weight of the edges. So what we have to find? We have to find the intersection between them. That is, we have to find what are the common edges and vertices in these both graphs. So how we will draw this? First we see which have the same vertices. So A and B. Here A and B is not present, so A and B is not there. Now CB, both graphs have CB and edge weight is also same. So we will make first this. Now we can see that BE is also there and has the same edge weight. So we can also draw BE, which has edge weight as 5. Now even CB is there, but both weights are different, so we can't draw that. But D, this loop we can see both graphs has D and same weight, so we can draw D as well at 7. And this is the intersection between G1 and G2, which we represent as G. So here, how we find out the common between these two graphs, which is also known as the intersection between the two graphs.
So the third operation is addition of a vertex. So basically in this we have a graph and we have a vertex V, which is not in G. Now what we have to do, we have to add V to G. So the new graph is denoted as V plus G. So we have taken here one graph, which is G, and now we will take another vertex which is not a part of G. So this is the graph G, this is the vertex V. What we have to do, we have to add this vertex into graph G. So how we will do that? We have to join all the vertices of graph G to the vertex V. So we will join it as such. So now we have joined all the vertices of G to V, and this graph can be called G plus V. This is how we add a vertex to a graph.
So the fourth operation is the deletion of a vertex. So again we take a graph if there is a graph G and there is a vertex in that graph which is V, and we have to delete that vertex from the graph. So what will we do if we want to remove V from G? Then we have to delete V from G, simple, as well all the edges which incident on V. We have to as well as delete those edges. So after deletion, the graph will be represented by G minus V. It will be clear by seeing the graph. So if this is the graph and these are the vertices and we have to delete this vertex. So what we will do like A, B, B, C and D. These are the vertices. We have to remove this one. So what we will do, we have to, and also the edges incident to these. So we also remove this edge, and this edge, and else we make the same diagram. So we connect A to B, B to C, and D will remain like that. And this graph will be presented as G minus B.
So the fifth operation is deletion of an edge. So here, if we have a graph G and we have E as any edge which is in G. Now, if we want to remove that edge E from G, then we simply have to delete the edge from the graph. We don't have to, like vertices, we don't have to remove the vertices or anything. We just simply have to delete that edge from the graph. After deletion of E from G, the new graph that we have is denoted by G minus E. So now here we have a graph G, and suppose we have to delete the edge E1 from the graph. So we will draw the graph like such. A, B, C, D and E, and we will draw all the edges except E1 because that's the edge we have deleted. All the other edges will remain the same. Now this graph is denoted by G minus E1 as we have removed the edge E1. Addition of an edge is similar to this. If we want to add an edge to a graph, we just simply add it and do not interfere with the vertices.
So the last operation which we will study for today is the fusion of vertices. So what happens in fusion of vertices if we have got to fuse any two vertices from the graph G, this is the graph GF, is an operation G in which two vertices are fused. What we do, we merge two vertices together without deleting any edge of G. So if we see this graph and we have to merge A to D. So what we'll do, we'll pick up this A and merge it to D. This is the alignment. How we draw this? First we'll draw B, C, D, and we merge A to D. So the alphabet which comes after, we merge the other alphabet to that. So A comes before D. So we merge A to D. So we make this will remain same. E, F, and we pick simply what will happen. It will go like this. So we have merged A to D. Now A and D are same. We have sum up. We have merged. So this is merging A to D. Now if we want to merge A to C, again C comes after A, so we merge A to C. So what we do, this D, E, F will remain same. But if we pick this A to C, this edge will also shift. So this edge will join B to C because it will shift. If A will come here, so this edge will also come here, and A and C are connected, so A will form a loop here. So I am merging A to C, the graph will look like this. So this is merging A to C. And if we want to merge E to F, these both are not connected. So how we merge them? A, B, C and D will remain same, and F comes after E, so E will be merged here. So it will simply form another edge like this. So this is merging E to F.
and navigation and analyzing traffic flow. Third is the computer science, where it is used for modeling computer networks and web pages. And the fourth being finance, where it is used for analyzing financial data and market trends. There are more applications to this, but here are just few that we have listed. This brings us to the conclusion of this video. Hope this topic of graph operations was clear to you all, and thank you so much for watching this video.